Alright, so this week we're going to look at two sections. We're going to look at section 3.1 and 4.1. So we're only going to do one section in chapter 3, and then we're going to skip the rest of it and go right to chapter 4. Section 3.1 is on what we call inverse trig. Okay? We're going to focus specifically on inverse sine, inverse cosine, and inverse tangent. There are three other trig functions. Remember the secant, the cosecant, and the cotangent. We're not really going to look too much at those. We might look at a little bit, but we're mostly going to focus on these three. So basically, anytime that you do something in math, there's an operation that can reverse what you just did, right? So for example, if you added something to a number, you can reverse that or undo it by subtracting, right? Let's say you were to square something. What's the opposite of squaring something? Square rooting, right? There's a way to kind of go back. Well, let's take a look at how we can do that with trig. Okay? It's called an inverse trig function. All right. So if I were to type in, let's just look at this. The sine, let's go like this. The sine of 30 degrees. This is the kind of problem you would have seen on the test last week. Okay, so if you didn't know how to do it, you would have found the coordinate, because that was the big thing with unit circle. You find the coordinate. And then does anybody remember what sine was? Was it the x or the y?
Y.
It was the y. Yep. And you would have written down the answer. Okay, this week we're not going to go through the unit circle stuff again. Just show you on the calculator what you get. Let's type in sine 30, and you get an answer of 1/2. Now, I'm going to show you how you can take the 1/2 and go back. That symbol that I just wrote, and I'm going to write this down in a minute, means inverse sine. Now, if I type that in, what do you think I'm going to get? The inverse sine of 1/2. 30, yeah, you get 30 degrees. So second, inverse sine of 0.5. And it goes back to what I started with. All right. So inverse sine gives you a way to get that. That thing that I just circled, it has a degree symbol on it. So what is that? What do we usually measure in degrees? Angles. So that's the whole point of inverse trig. Inverse trig lets you figure out an angle. Last week, I gave you the angle, and you figured out something else. This week, I'm going to tell you the something else, and you're figuring out the angle. So it's almost like the exact opposite of what you did last week. Right. So I told you I'd write down all the symbols. These are the three symbols that we're going to focus on. Inverse sine, inverse cosine, inverse tangent. You basically write the trig function, and then it kind of looks like you've got a -1 as an exponent, but that -1 is not an exponent. I know it's written up a little higher, and that's normally where you would put an exponent, but it's not. All that -1 means is inverse sine. And what's kind of tricky about putting a number right here is if you put any number there other than a -1, it is an exponent. The only time it's not an exponent is if you put a -1. Just think of the -1, it's a special symbol. It's kind of a special symbol that just means inverse sine. Now next to it, I wrote this other thing. I wrote arc sine. Same thing. Okay, arc sine is kind of an older way. If maybe you have some textbooks a little bit older, you might see the words ARC sine. It's exactly the same as putting a sign with a -1, just a different abbreviation. I usually stick with the -1 notation, and so would your calculator. Okay. It'll use the -1. So, whenever we use inverse trig, like you could try it and kind of see what happens. You could do inverse sine of, let's go, 0.8. Inverse sine of 0.9. Okay, and you could kind of look for a pattern where for the answers you're getting. Okay, we got 30, we got 38, 64, negative 30. Well, all the answers that you're getting right here are always going to be between negative 90 and 90. You'll never get an answer that's not between negative 90 and 90. I'm going to go right back to that. And now, I want to look at why. Why are they between negative 90 and 90? Well, I'm going to show you guys a table. And I'm going to show you a problem that we run into if we don't let the answers be between negative 90 and 90. And so inverse sine will always give you an answer between negative 90 and 90. Including, that's why I put the equal to. So it can equal 90, it can equal negative 90. All right, so let's look at this. All right, what I want to do is I want to make a table of some different trig functions. All right, so I've got 30, 65, 90, 150. Okay, and I'm going to type them all in, and I just want to see what I get. Okay, so let's start with 30. Sine 30, we already did that one, gives me 1/2. Okay, let's do the sine of 65. I get about 0.91. Okay, I'm just rounding it to 2 decimal places, that's fine. Let's do the sine of 90. 1. All right, and we kind of already did this a little bit, but if I did the inverse sine of 1/2, what number would I get? 30. What if I did the inverse sine of 0.91? What would I get? Yeah, maybe I'd get about 64.999 because I rounded it. And what if I did the inverse sine of 1? I would get 90. Right? Well, let's do the sine of 150. 1/2. Anybody see what the problem is now? What just happened?
30 and 150 are the same.
Right, we have 2 numbers in the right column that are the same. So now the question would be, well, what if I did inverse sine of 1/2? I am going to get 30. If I do inverse, we just did it. Inverse sine of 1/2, it doesn't give me 150. It gave me 30. But the sine of 150 is 1/2. So it's like there's another answer, right? But we don't use that one, right? And the reason why we don't use that one is because we want to get one answer to all these problems. So if we would say, you know what, we're always going to take the answer between negative 90 and 90, you will never get more than one answer, all right? And the reason why you get more than one answer is because, let's take a look at this line. I'm going to try to put it right at 1/2. Okay? Each mark going up and down is 1 unit. And going down as well, -1. Okay, so I put a line in right at 1/2. I'm going to just, right where that black line crosses the blue one, I'm going to put a dot. Okay, when you're looking at that graph in blue, that's the graph of sine, right? That's what it looks like. We're going to look more at that graph next week. So you don't have to know how to graph it right now. I just want you to see where the graph of sine, which is what's in blue, and the line at 1/2 cross. They cross right there. That red dot is 30 degrees. This red dot is another time that it crosses. It's 150. And I could come up with more and more answers. I could do the sine of 390. There's another one that comes out to a half. That one is over there. I could do, let's see, do one more. Let's do the sine of 4, no, not 410. Let's see, it'd be 150 plus 360. 510. 510. Sine of 510. Another answer that's a half. That one is over here. So basically I could continue this forever. I could keep finding numbers that I could take the sine of and get a half as an answer. So what we always do, here's negative 90. Here's positive 90. Now, you can ignore everything else that's outside those red lines. If I take this black line and start moving it up and down, just look inside the red lines. Does it ever hit the graph more than once in that blue section? No matter where I put it? No. As long as you stay between negative 90 and 90, and there's other sections that would work too, but this is one section that works, and you never have the black line hit the blue line more than once, which means you will never get more than one answer, and that's what we want. Right? And that's how your calculator does it as well. It always will give you an answer between negative 90 and 90. If it didn't, then you'd have more than one answer, and that's not what we want. Okay, so for inverse sine, it's always between negative 90 and 90. Well, cosine has the same problem. Okay? The graph of cosine kind of looks like a wave again. Let's take the cosine of, let's do 30. And I get that number. All right, now let's do the cosine of 330. How do those two answers compare? They're the same, that's the problem. So now we're saying, well, what would happen if I did the inverse cosine of 0.866025? I'm not going to type it all in. But the question is, which answer would it give me? It can only give me one. Is it going to give me 330? It's going to give me 30? Which one? Anyone have a guess which one it's going to give me? 30? Yeah. And again, it gives me 30.00000 because I rounded. But it gave me the 30. So when we're dealing with inverse cosine, the calculator will always give you an answer that's between 0 and 180. And it does that to avoid the problem of having more than one answer. Okay. Below each angle, I'm writing the answer in radians as well. So you've got negative pi over 2 to pi over 2. It's negative 90 to 90. And 0 to pi. That's 0 to 180. And now, I'm going to show you the graph of tangent. Okay, both sine and cosine kind of look like a wave. But let's look at what tangent looks like. Has anybody seen the graph before? No. There's a pattern to it, but it's definitely not a wave. It's kind of like these curves that just keep repeating. So my question is, if I put a horizontal line in that graph, would it hit the blue curves more than once? Yes, it would. That's a problem. That means that you would get more than one answer. So what we're going to do is we're going to pretend like most of those curves don't exist, and we're just going to look at one of them. If we just focus on one of them, pretend the other ones don't exist, which is okay to do, we will only get one answer. And the one we're going to look at is just this one. We're going to pretend that the rest, we just ignore it. So all you want to do is look at that one I was kind of tracing in the middle. We're going to limit inverse tangent to always giving us an answer between negative 90 and 90. So what these different ranges are going to help us do is when we're looking at this chart and we're trying to find an answer, if you find more than one, give me the one that fits in these intervals. Okay? If you're dealing with inverse tangent, always give me the one between negative 90 and 90. Now, what's the difference between the negative 90 to 90 for inverse tangent and for inverse sine? They're not exactly the same. Yeah?
One's equal to, one's not.
Right. You can't take the tangent of 90, right? If you try, remember last week we ended up with this calculation sometimes? 1 divided by 0, when we did y over x. That's basically what's happening when you try to do this. You can't equal 90. You can do 89.9, you can go right up to it. That's fine, but you can't do 90, right? And you can't do negative 90 either. And that's why when you look at this chart, I'm just going to kind of skip ahead to a page that has the chart on it. Tangent of 90, undefined. Tangent, negative 90, undefined. Can't do it. Okay, so those are undefined. And there's some other ones that are undefined as well. But when you look in the sine and the cosine column, you will never find an undefined. Any other column, yes, but not sine and cosine. Okay, so any questions on those different intervals? Okay. All right, so let's kind of compare this to what we did last week. I'm going to explain, and I kind of already did, but I'm just going to explain the kind of question you would have seen on the test last week and how this week it's going to be backwards. Basically the same thing, but it's the opposite. All right, so last week, this is what we did last week, unit circle trig. I gave you an angle, like 30 degrees. And I said to you, what is the, and then I picked a trig function. What's the cosine? What's the tangent? What's the secant? What's the cosecant? But the point is, I picked an angle and then asked you to find the trig function. Okay, so you were given an angle. And you found the trig function. This week, it's reversed. You're not going to find the trig function. I'm going to give you the trig function. Right? So you're going to be given the trig function. Like that. 1/2. The question is going to be now to work backwards and figure out what angle am I thinking of. So if I said to you, like in my head, I'm like, okay, I'm thinking of an angle, and the sine of this mystery angle is 1/2. You tell me what angle I'm thinking of. That's the kind of question you're answering this week. So any question on the difference, like what you did last week versus what you're doing this week? So this is the whole goal. You're figuring out the angle versus last week you already had it. Okay. And if you're wondering, well, where does figuring out the angle come in? Well, when we get into a problem like, let's say, I give you a triangle and I tell you 2 of the sides and I say, how big is that angle? You would use inverse trig to figure that out. Okay. That's what we're learning this week. All right, so how do you know when to use this table? Okay, because this table that I gave you, I'm just going to skip ahead to a page that has it. This table doesn't have every single angle in the world. That's impossible. But does anybody notice a pattern to the angles that you see in the table? Look at the angle column, and then just go down the angle column and see if you notice anything about the angles. Like you don't see 57.6 degrees.
It's all the easy triangles, like nice ones.
Yeah, it's all the angles from the triangles we did. It's all your multiples of 30, and it's all your multiples of 45, right? So that's when you can use this chart. Okay? If it's not a multiple of 30 or 45, you can't use this chart. So how do you know if it's a multiple of 30 or 45? Because that's the answer to the question. Okay? You're actually trying to find the angle. You're not going to know this number when you're doing the problem. But what you are going to know is those numbers. Okay? So the way you know that if you should use this table or not is you're looking for numbers like we used last week. Root 3 over 2s, root 2 over 2s, 1/2s, square root of 3s, negative halves, negative of anything I just said, zeros, ones. So if you see a problem that has anything with square root of 3, square root of 2, anything like these numbers, that's how you know to use the table. Okay? So look for those numbers in the problem. And the negatives of all those numbers as well. If you saw a problem like this, inverse sine of 0.625, well, you can look for 0.625 in the table, but you're never going to find 0.625. That's not a number in the table. So how would you do that one? We use the calculator. Okay, and I'm going to show you how to type it in later on, but all you have to do to type it in, it's that easy. And that's the reason you don't see it in the table. It's not a multiple of 30. It's not a multiple of 45. It's not a nice answer. Okay, so what we'll do, we'll practice going through using this table. We'll do some inverse sine, some inverse cosine, some inverse tangent. You also have the cotangent, secant, and the cosecant, but we're not going to use those. Not for this table. Okay. Does anyone still need to copy that? All right. Okay. So if you were using this table last week on the test, okay, you would have had a question like this. Sine 60 equals. Okay, you don't have to write this one down. This is like a review. You would have said, okay, I'm going to go to the column until I find 60 degrees. Okay? Right there. What trig function does he want to know? Sine. So I'm going to go over to the sine column. There's the answer. That's how you could have used this table on the test last week. Now, instead of looking up the angle and then going to the column for the trig function, we're going to do it in reverse. We're going to start in the column for the trig function. So let's go to the sine column and look for the number 1. Okay, so in your table, start in the sine column and keep going down until you find a 1. Okay, and I'm gonna circle it. You don't have to circle it on yours because then you'll have circles all over your sheet. Right there. Now I'm going to keep going and see if I see it again. Okay, I see root 3 over 2, root 2 over 2. I see a negative 1, but that's not what they wanted. They wanted a 1. Okay, so I only see it one time. So I got the number I'm looking for. And now I read backwards, and I get the angle. So the angle in this case is 90 degrees. So the inverse sine of 1 is 90 degrees. Okay. Another way to think about it, if you're kind of like, I'm still not quite sure, is you basically just figured out this question. The sine of what angle would give you 1 as an answer? We just found it. The sine of what angle would give me the answer of 1? It would be the sine of 90. Okay. let's try this one. Okay. Another way to think about this one. The sine of what would give me -1 as an answer? Solve for the question mark. That's what I want to know. What angle could you take the sine of and get -1 as an answer? Now, if you look on your chart and you get more than one answer, remember, we're looking for the answer between -90 and +90. If you only get one answer, then that's it. There's only one answer. Okay. Anybody think they got this one? The sine of what angle comes out to -1?
Is it -90?
Let's take a look at the chart. So we go down the sine column. I see -1. And now I have a choice. On your chart, there's two numbers written, 270 and -90. How do I know which one? We just went through that. Always give me the one between -90 and 90. So it's -90, or if you wrote your answer in radians, -pi/2. Okay? So both the radians and the degrees are on the chart for you. So those aren't two different answers, they're the same answer. One's radians, one's degrees. Okay, let's try this one. The inverse sine of a half. So I'm trying to find an angle so that when I take the sine of it, I get 1/2. Now make sure you're not accidentally in the cosine column. Some people look up the wrong column because you'll find 1/2 in the cosine column too. Look for it in the sine column. Okay. Anybody tell me where they see the number 1/2 in the sine column? Yeah. 30 degrees. Is there anywhere else that it comes up? 150. Remember we did this. I have to scroll down. 150. We did that one earlier. Came up in two spots. So now, technically, you have four choices you could tell me. 150, -210, 30, -330. Out of the four, which one is it? 30. Why?
Under 90.
It's under 90, and it's more than -90, right? Always looking for the one between -90 and 90. And if you wanted, I mean, you really don't need to because you got the chart. If you wanted to check your answer, plug it in. Take the sine of 30, and yes, you do get 0.5. Go. All right, let's try this one. The inverse sine of √2/2. Or, think of it this way. The sine of some mystery angle is going to give me √2/2. Find that angle. Okay, so let's see. Anybody tell me where that one pops up? 45. Yep, it pops up under 45. Anywhere else? 135. And that's it. You'll only see it pop up in those two spots. You might see -√2/2 somewhere else, but not √2/2. Okay, and which one do we go with? 45, because that's the answer that's between -90 and 90. It's not that the other answers are wrong. They are right. But when we're doing this kind of problem, we want to have one answer. And that's the one we go with. 45 degrees. What if they wanted the answer in radians? What would you write? Pi/4. Same thing. Okay, let's try one more with inverse sine, and then we'll move on to inverse cosine. inverse sine of negative root 3 over 2. That negative is important, so make sure you don't accidentally look up the positive. Okay, so we're looking for negative root 3 over 2. Devin, do you see where negative root 3 over 2 comes up in the sine column?
240 degrees.
Okay, I see it at 240. Anywhere else? 300, yep. Okay, so out of the 4 numbers I just circled, one of them is correct. Negative 60, yep. So we're going to go with negative 60. Or if they wanted it in radians, you would do negative pi over 3. Okay, any questions on that? Basically the same thing for inverse cosine and inverse tangent, so we won't do as many. Okay. Let's try inverse cosine of 0. Now, we got to kind of switch gears here. Inverse sine is negative 90 to 90. What are we thinking we need to be between now? It's not negative 90 to 90 anymore. It's 0 to 180. Yeah. So forget about negative 90 to 90. We're going 0 to 180. Okay, so in the cosine column, where do we see 0? Yep. Anywhere else?
270.
270. Now, if you still had the negative 90 to 90 in your head, you'd get stuck here. Because you'd say, well, there's 2 answers. I have 90 and I have negative 90. Well, it's not negative 90 to 90, it's 0 to 180. So there is only one answer. What's the one answer here? 90. Yep. Okay, so I've got 2 more with inverse cosine. Take like 30 seconds on your own and see if you can find those 2. Inverse cosine of negative 1/2 and the inverse cosine of negative root 2 over 2. Alright, so inverse cosine of negative 1/2. Alright, so Connor, where do you see that one? Inverse cosine of negative 1/2.
I see it at 140.
Yep, I see it at 120. Now I already know that's the answer because I'm supposed to be between 0 and 180. So even if it comes up somewhere else, which it will, we don't even have to really worry about that other answer. So the answer is 120 or 2 pi over 3 radians. Alright, 120. And negative root 2 over 2. Yeah.
135.
Let's see, 135, negative root 2 over 2, we're in the right column. Yes, 135. Again, it will come up somewhere else, but we don't need that one. Okay, so any questions why it's 135? Okay, so let's we'll try a couple with tangent, and then I'll show you how to do these on a calculator. Okay, so take a second, try those 2, and I'll get some calculators out if you want to practice typing it in. It's not that hard, but it is something you got to know for the test. Okay. So inverse tangent of root 3. Someone remind me, just so we have it on video, what are we supposed to be between again?
Negative 90 and 90.
Negative 90 to 90. Did anybody see an angle between negative 90 and 90 that if you took the tangent of it, you would get square root of 3? 60, yes. And you're going to see it somewhere else. But those two answers are not between negative 90 and 90. Right, so we go with 60. Right, and last one, inverse tangent of negative root 3 over 3. Yep, I see it. Negative root 3 over 3. I got two answers to pick from. Make sure I give the right one, negative 90 to 90. Negative 30 fits in there, perfect. So that's your answer. And we haven't done a radian one in a while. What would you write if they wanted it in radians?
Negative pi over 6.
Yep, negative pi over 6. Degrees and radians. Okay, so that's how you can use the chart. So now, if you can't find the answer using that table, then we're going to use the calculator. Like 0.65. Inverse sine of 0.65. If I go back and I look at my table, is 0.65 in the table anywhere? I think I would. Is 0.65 in the table?
No.
No. I mean, you got 0.5, you got 1, you got negative 1, a half. 0.65 is not in the table. So, we're going to use a calculator. So let's see what we got. So to type inverse trigon on my calculator on the board here and on the ones that you usually borrow, you have to press second and then the trig function you want. Okay, but you press second first. And now you type in 0.65. So I got an answer of 40.54 degrees. Or, if I wanted the answer in radians, I have two choices. Convert that to radians by hand. So I could take and multiply by pi and divide by 180. And that's the answer in radians. 0.7, about 0.71. Now, if I had to do that in radians, I probably wouldn't have just converted it like I did by hand. I would just change the mode to radians and type in the same problem again. Inverse sine of 0.65. I got exactly the same thing. Okay. Why do you think I would change the mode and do it that way rather than converting it by hand like I did here?
Less chance to mess up.
Yeah, less chance to make a mistake, so that way, if the calculator's changing it for you, you're not making an error in that spot. All right, so that's how you do it. Now, let's say this was a multiple choice question on a test. And the answers were 40.54, 0.65, 0.71, and apple. Which answer there is correct?
C.
C. Okay, C is definitely the correct answer. Any question why it's not A or B? Now, very small change. Which answer is correct now?
A.
Now it's A. You are going to see that on the test. Okay, it's checking to see if you know, are you in radians or are you in degrees? All right. So you'll see the same answer listed. It's just check what mode you're in. If the multiple choice answers have the little circles above them, then you need to be in degrees. If they don't have the little circle, you need to be in radians. All right, let's try this one. Inverse cosine negative 0.24. Aiden, can you tell me how I would type that one in? Well, very similar to the last one, we just got to use a different button. What button did I press first last time?
The second button.
Yep. And then what do I press from there? Cosine. Okay, keep going.
Then don't you type in the negative 2.4?
Negative 0.24, yep. And we get an answer of, now that's in radians, 1.81. I'm going to do it in degrees. And what do I already know? The calculator is going to give me an answer between what and what?
0 and 180.
It's going to give me an answer between 0 and 180. 103.87. Okay, you should be comfortable with doing it in degrees or radians. I did both, I just didn't write both. Okay, and inverse tangent. Okay, so inverse tangent of 34.3. Now, remember this right here, that's not a radian or a degree. That's a trig function. It's just a number. That's all it is. It's just a number. Once you type that number in and hit enter, the answer that you get right here, that's what's going to be in a radian or degree. The answer, the arrow that I'm pointing to, that number, has no label. It's just the number 34.3. Alright, so let's type that one in. How about Jake? Can you tell me how I would type that in on the calculator?
Hit tan. Sorry. And then in the parentheses, put 13 or 34.3 in close parentheses.
So tan like that?
34.3 and then close parentheses.
Now,
No.
look at that function there. Does that one match that one? Look at it.
No.
What am I missing?
Missing the -1.
Right. How do I? What button do I have to press first before I press tangent?
Isn't it? Oh, the negative button down there.
Not the negative. We would use the negative on a problem like that with the negative 0.24. But does anyone remember what do you have to press first? Second.
Second. Yeah.
So second tangent. That's how you get inverse tangent. Right. Then you can type in everything you said. That part was good. So we get 88.33. Okay, questions on that one? Alright, so I want to do, don't write it yet, but I want to do that problem in a minute. But don't write it yet. Why is that one a little harder to do? I mean, it's the same kind of equation. It's an inverse trig function, then a number. But there's something harder about this one. Yeah?
Because there's no secant button on your calculator.
Yeah, there's no SEC button. I don't have a button for it. So somehow I have to use one of the buttons that I do have. Okay, and you can, and that's what I'm going to show you, which button to use. So let's say you had to do an inverse secant problem, right? The goal, when I'm done, is to have a different formula for y. I want a formula that doesn't have SEC in it. I want a formula that has one of these three in it, because I have a button. Alright, so I'm going to show you there's basically two steps. You're going to kind of see a pattern, and the same pattern is going to work for all three of these, how you type it in. Alright, I want to start by canceling out inverse secant. So what function is the opposite of inverse secant? Close, you're thinking of something else, but we're going to come back to that. Someone else said it. Secant, yes. So what I'm going to do is I'm going to take the secant of what's on the left. I'm going to take the secant of what's on the right and just squeezing it in by the y. I didn't have enough space. Those cancel out. Now I don't have an inverse trig problem anymore. I have an x all alone on the left, and on the right, I have secant y. It's the same equation as what I had up above. It's just rewritten a little bit. Now, secant. Does anybody remember from last week what function you flip and it gives you the secant? The cosine. So what I want to do is I want to flip each side. Now, this isn't a fraction, but I could pretend it's a fraction by putting x over what number? 1. Right? Now we've got something we can flip. Aaron, if I flip x over 1, what do I get? Just 1 over x. Equals, and what did we just say? If you take the secant and flip it, which trig function does it turn into? It turns into the cosine. So now I've got rid of SEC. I have a different trig function there. I flipped each side. When you flip x over 1, you get 1 over x. When you flip secant, you get cosine. And now, the last thing I'm going to do is I'm going to take the inverse cosine of each side. I'm going to do it on the left, and I'm going to do it on the right. What do you think cancels out on the right-hand side when you do that? You have inverse cosine and regular cosine. Jasmine, can you guess what cancels out?
Cosine?
The cosine and the...
Inverse cosine.
It cancels out the inverse cosine. So what's on the right-hand side now?
Y.
We got y all by itself again. That's exactly what we started with. We had y all by itself, but look at what we have on the left now. That's a different formula than what we started with. So if you want to do the inverse secant, you can't. You don't have a button for it. But what you do have is a button for inverse cosine. So you have to take the number that they're giving you and flip the number. A little different than last week. Last week we flipped the whole trig function. All you have to do is flip this number and use inverse cosine. Okay? So let's try it. So when you see inverse secant, change it to inverse cosine. But you can't keep it the same. It's not inverse cosine of 1.45. It's 1 over it. And that's the only way to type in inverse secant on the calculator. Switch the trig function, flip the number. Okay, let's see what we got. Second, inverse cosine. 1 divided by 1.45. You should get about 46 point, if we round up, 46.40. Okay, so that's inverse secant. So for that one, I'm just going to write it up above. We used inverse cosine. How about cosecant? Anyone remember from last week which trig function? Yep, we're going to use the inverse sine to do that one. And then what about cotangent? We're going to use the inverse tangent. So up above each trig function, I wrote the one that you switch it to. So you switch it, and you flip it. Switch, and flip. Alright, so let's try this one. Inverse cosecant of 2.6. First thing you do, switch it. What trig function am I going to replace inverse cosecant with? Inverse sine, yes. So I switch the trig function, and now what number goes in the parentheses? 1 over 2.6. Yep. Okay, so let's see what we get. Inverse sine of 1 over 2.6. Okay, anybody with a calculator tell me what And you got first. We'll see if you did it right. Yep.
2.2.
You got 2.2
Oh, yeah. I thought, yeah.
in your degrees.
Yeah, I'm in degrees.
So on that calculator, I'm pretty sure you have to type it in backwards.
Yeah.
So you would have to do 1 divided by 2.6 and then do inverse sine, like that. And you'll get the same thing, 22.61. You just have to type it backwards. Okay. Any questions on, or actually 22.62. Okay. Any questions on? Did you end up getting it yet, or is it still?
I'm still trying to
You're still trying? Okay, we can look at it after if you're not sure. We'll take a look. Okay, and the last one, inverse cotangent of 0.35. Okay, Kyle, what do I have to do first there? Not sure. So 2 things. Can somebody tell me the first word I said? Yep.
You gotta flip it to inverse tangent.
So first thing is what's the first thing? Because you said kind of 2. So what's the first thing you do? Well, flip it is one thing. So doing the flip is one. What's the first thing you do? You said it. I just kind of want to separate it into 2.
Oh, inverse tangent?
Switch the trig function. Switch it, flip it. It's like set it and forget it. Switch it, flip it. Switch the trig function. And now the last thing is flip it. So Kyle, what's going to go inside those parentheses? Not sure? Anyone help him out? Well, tell me first, what am I flipping? Don't even tell me what I get. Just tell me what to flip. Yep? The number right in the parentheses, the 0.35. So is that a fraction the way it is right now? No. How could I make it a fraction? Yep. So now, if you flip that, what would it look like?
1 over 0.35.
That's what you put inside here. And that's what you type in. Okay. Inverse tangent, 1 over 0.35. So switch the trig function, then flip it. Okay, 2 things. Second, inverse tangent, 1 over 0.35. Okay, so you should get about 70.71 degrees. Any question on how you do that in radians? Wouldn't be any different when you type in. Just change the mode. Okay, so any questions on what we did today? Going over that chart or using the calculator? All right. So homework tonight is on 187. We've got just over 15 minutes. Okay, so please use this time to try to get started. If you need a book, there's an extra one up there, especially on the calculator ones. If you don't have a calculator at home, you might want to do those first right now. Okay. So it's 13 to 17, 19, 20, 22 to 31, and 33, and that's all. They all.